There we are. Okay, so this is video review number 2. And this will be derivatives and integrals of exponential functions. Okay, so here's the typical problem. F of x e to the 3x plus 1. What is the rate of change? And in fact, to make it a little bit more intriguing, let's ask what is the f prime and also f double prime. And in fact, let's find the 10th derivative, right? So if we can find the first and second, there should be an obvious pattern, and you should have the 10th. So let's see. The derivative of any, here's our operative rule. If you've got f of x is e to the x, the derivative of that will simply be e to the x. Using the chain rule, if we have f of x is e to the u, the derivative will be e to the u, but don't forget you need du dx. Okay, so that would be the chain rule coming into play. And these should allow us to answer these questions pretty easily. Okay, so first derivative. The derivative of e to the 3x would be e to the 3x plus 1, right? The derivative times the derivative of that, which would be 3. And almost always we're going to be putting that in the front. So you'll never see times 3 at the back. This would be written as e to the 3x plus 1 times 3. And so there's our first derivative. Second derivative. The second derivative is the derivative of the first derivative. So this 3 comes straight down, and we know what the derivative of e to the 3x is. That's 3e to the 3x plus 1, right? So now we have 9e to the 3x plus 1. It certainly could be. Second derivative, 3 squared. So the 10th derivative, 3 to the 10th, e to the 3x plus 1. You got it. Done. Okay, so there's an exponential function using the chain rule multiple times, finding derivative of e to the x. Let's find the antiderivative. Okay, so let's suppose we had to find the antiderivative, and we're going to use the same function here just to make things a little bit consistent. 3x plus 1 dx. Now, like we had the derivative rules, we've got the integral rules. The integral of e to the u du is e to the u. In this case, you should probably note this is u. Most of you can do this in your head, but if you have to write down, u is 3x plus 1. Du is supposed to be 3 dx. And you look over here, and there is no 3 dx. So we'll go ahead and multiply by 3, right? And divide by 3. So now we're good. We have the answer, 1/3 from here. And the integral of e to the u du is e to the 3x plus 1. Okay? So not too bad. Let's tweak this and just look at a couple of variants. So if we had the integral of e to the 3x squared plus 1 dx, unfortunately this one you can't do. Note that u is 3x squared plus 1, and du would be 6x dx. It's easy to get the 6 in with 1/6, but we're not allowed to introduce this variable. You can't put an x in here, no. Okay, so because the x is missing, this problem you can't do. Okay, so, well, it's interesting. We can do this with infinite series. There is no closed form. In other words, there will not be one function that this will equal to, but it can be written as a function of an infinite number of terms, and that's April. So when we do infinite series, we'll come back and look at a problem like this and write down the derivative or the antiderivative, but it will have an infinite number of terms. It won't be a closed form.
That was my question.
Well, you said, what is the answer, right?
What would you put?
I'm not going to give you that because you can't do that. Okay, but I will give you this. Suppose I now, well, you don't need to have a 6x. That's the idea. Suppose I gave you this. the integral of 5x e to the 3x squared plus 1 dx. And now this is one that you can do. So we go off to the side and we say our u, remember we're using this idea, the integral of e to the u. So our u is 3x squared plus 1, and our du is going to be 6x dx, and we need that in the problem. Well, we've got a 5x dx, but we need a 6x dx. We can't multiply or add an x, but we can do this. We can certainly take the 5 out. So this will be 5 times the integral of x e to the 3x squared plus 1 dx. And we can truddle this x right here back to here. So that's easy enough to do. And then we can insert a 6 as long as we compensate with a 6. So yeah, this problem wasn't impossible. The presence of the x made it workable. So we needed that. Here's your final answer for this black antiderivative up here. It's going to be 5/6 e to the 3x squared plus 1 plus a constant. Okay? Now, whenever you're doing integration, you can check. If I gave this to you earlier up in the page, way up here when we were doing derivatives, say I gave you this as a function to take the derivative of 5/6 e to the 3x squared plus 1 plus any constant. Sorry. Okay. And I were to ask you what is the derivative of this, using the derivative rules, you should be able to come all the way back to this antiderivative integrand. You should be able to come all the way back to here. So if we can get that, when we take the derivative of this, we'd be in good shape. Okay, so here's the derivative, 5/6. The derivative of this part would be e to the 3x squared plus 1 times the derivative of 3x squared plus 1, which is 6x. The derivative of 17 is 0. So sure enough, we get 5x e to the 3x squared plus 1, which was our integrand up here. Okay, so we have the right antiderivative. Okay, so that's derivatives and integrals of exponential functions. Do you have to worry about bases other than e? Probably not. In May, I doubt that you'll see this question, 2 to the sine x, what is f prime? But if you were, this is the answer. You write down the exponential again, 2 to the sine x. You use the chain rule, which is going to be the derivative of sine is cosine of x. But there is a constant multiplier here. Yeah, the number that you have to multiply this by is the natural log of the base being 2. Okay, so yes, f prime, and just sort of string these together. I don't know that there's a better way of doing that. Maybe natural log of 2 times the cosine of x times 2 to the sine x. Okay, and again, this is just a constant multiplier. Which brings up an interesting question. Suppose I gave you this as a problem, and you gave me that as an answer, and then I gave you this. What is the antiderivative of the natural log of 2 times the cosine of x times 2 to the sine of x dx power? Now, this is a horrendous looking integral, and we have no techniques. We have no techniques for finding antiderivatives of product. There is no product rule. And yet you now know the answer. Right. We know that the derivative of this is that. So the antiderivative of that has to be this. The answer is, in fact, 2 to the sine of x. Don't forget to add a constant. Okay? So maybe a bonus question on tomorrow's test. You're not going to see it in May. Something similar to this. Yeah. Oh, well, such is life. We're going to stop this guy right